Thank you so much for being here. The competition is tough, so I'm happy to see so many of you here. And we're going to talk about building resilient integrations. My name is Martin Gunnarsson. I am head of development at Parkster. And I might not be an expert integration developer myself, but I have picked up a few things along the way that I want to share with you today. And I'm also not a superstitious person, except for when it comes to jinxing things. So it feels a little bit reckless standing here talking about a topic like this. But let's knock on wood, right? And my phone is firmly in flight mode so that both you and I can be blissfully unaware of any alarms going off in the next 40 minutes or so. So Parkster is that green parking app that I hope most of you know and love. The company has been around since 2010, and we are approaching 90 employees now. Our headquarters is in Lund, just north of Malmö. And we also have an office in Munich, and our services are available in well over 1,000 cities throughout Sweden, Germany, and Austria. But from a system perspective, the app is just one portion of what we do. Most of our code actually lives on the back end, where we have a service-based architecture with quite a few different services of varying sizes, communicating with each other by submitting events on message queues. This is obviously a very simplified view of the world, just a sketch. We have many different services with integrations in all directions, basically. And if you look at what we offer, like we offer payment for parking, so our integrations with various payment methods are probably the most critical ones, very important to our service. But there is also integrations to things like wardening systems, allowing traffic wardens out there to see that you have actually purchased a ticket, a parking ticket for your car when you have done so. So that is pretty critical as well. Then we have a number of more product integrations, as we call them. Integrations, for example, for camera parking systems, EV charging, like you can start and stop charging of your electrical vehicle through the Parkster app. And for statistics, for authorizations, for discounts, and so on and so forth. And we basically never have any deals without at least one or two of these product integrations. And they are essentially what makes us so useful. They are a critical part of the Parkster experience. And all of the examples I just gave you are external integrations. But I think we should also keep the internal ones in mind, because even though these operate in a much more like a controlled environment, maybe, these too require some careful thinking and tuning, and the occasional love and care as well. So in this talk, I'll mostly focus on the technical aspects and methods of building a resilient integration. But before we start building anything, it's always good to do some planning. But like with many other things, an integration like this is not something that you just plan up front, execute, put into production, and everything just works. We must instead plan for uncertainty. And I really like this quote, because a static plan can literally be outdated like the minute it's written, but the act of planning is still really useful and important. It forces us to consider different scenarios, different risks, different priorities. And all of this thinking and planning gives us a mental model like of the situation, of the landscape. And this mental model really helps us to respond quickly and intelligently when things go wrong. And go wrong they will, right? So the integration isn't static either, at least most aren't. They're more like a relationship that evolve over time. So in addition to the technical parts, we should also plan for this collaboration. And this collaboration usually happens across boundaries, like we integrate with services from another company or maybe another department if we're a bigger company, or just another team. And these groups of people might have different ways of doing things. They might use different words to describe the concepts we're talking about. They might have different cultures, and yeah, it's just very worthwhile to spend some time ahead of things to sit down and discuss, like, when you say that, what do you actually mean? Oh, we call that this instead, and agree on a vocabulary to use when discussing these matters. And communication is also really good to put in place up front, like how do we communicate? For simple ad hoc, quick communication, can we have a shared Slack channel? We do that with some partners. It's very useful, a very quick way of getting in touch with somebody. But there should, of course, also be like proper escalation paths. Do we have support during the weekends, or how do we get help when things aren't working the way it's supposed to? But we shouldn't just focus on reactive communication either. We should be proactive with that as well, to set up some kind of a recurring meetings. They don't have to be that often, but it's good to get in touch, see how everything is working, and have a bit of a plan for that, and to make sure that we have a process for how to introduce change, talk about change, roll out changes, and so on. And finally, I think it's really good to define responsibilities and mandates in this relationship. Like for us, it's when we set up a camera parking integration, for example, it's very good for us if we identify like a bad ticket, this parking session isn't correct. Are we allowed to set the price to 0? Or do we have to ask the partner to do that? Or do they have to ask the parking owner to do that? And having these things in place is really, really good. And I'm not just saying this because we are so good at this all the time. We are getting better, but I've seen how frustrating it can be when these things are not in place. Like, this is down. How do I contact these people? Who are they? Where are they? That's not a good place to be in. So we should plan a little bit ahead of time and write these things down. Because teams change as well, probably on both sides. So having this as a shared document is a very good starting point. And these days we actually have a dedicated integration manager, a person responsible for ensuring we have these things in place, at least for our product integrations. And then there are technical things we can agree on as well. What's success, what's failure, how quickly can we ask each other things, how quickly can we expect a response, and so on and so forth. And again, write this down. So once we have established some aspects of this collaboration, how to work together across the boundaries, then I think it's time to start looking into actually building something. So integrating between two services doesn't sound that difficult. We send a request, we get a response. Just works, right? Doesn't seem that difficult. But there are a thing or two that can go wrong. These are the classic fallacies of distributed computing, which is essentially what we're talking about here. Like the network is reliable, latency is 0, right? But many systems still seem to be built as if these misconceptions were true. And then people are all surprised when things go wrong, right? But if we have a really, like a non-critical integration, more of a for your information integration, this is fine. We shouldn't just add things because we, for the sake of technology. If it's okay to lose requests when any part of this chain is down, this is perfectly fine. It's just that in most cases, that's not the situation we're in. We usually need many more safeguards in place. So if we look at an example from Parkster, again, a very simplified view of the world, but I hope it conveys the message. When you want to start a parking in the Parkster app, the app sends a request to our backend, and then that ends up in something that we can call the parking service. And here we have a number of business rules, configurations, calculations to take care of. So quite a bit of work goes into this to make sure that it is actually okay to start a parking here and that it was successful. And then we can tell the app that thumbs up, you're good to go, enjoy your day. But then we have all the other services here as well. And it's important that we tell those as well about this newly started parking, the newly created parking ticket. Because there we have things like the warden service taking care of this traffic warden thing we talked about, so that the traffic wardens can see that you have actually bought a ticket. Important, as we said. But also our order service, for example, that we use to get paid for the parking, so that we can pay the parking owner. Pretty good for us as a company, if that equation works. So we have a number of services that are really interested in knowing about parking tickets when they start, when they are ending, and so on. But there's a bit of a flaw here, right? Probably multiple, but the one I'm thinking about is, what if we crash? Or what if the service is restarted in the middle of all of this? And we can't really send this message before we have started the parking. So having something go wrong or happen in the middle of all of this, it puts us in a very bad, inconsistent state across the system, and that is something we really want to avoid. So what do? We must find a way of communicating with the other services and start the parking simultaneously as one atomic operation. And we do that using the database of the parking service here, where we use a single transaction to write both to the parking table, or the parking ticket table, as well as an outbox. And that outbox is essentially a little queue of messages that we want to send to the other services. And we do this in one database transaction, which is what gives us this atomic operation, because they will either both succeed or they will be rolled back as if nothing happened. And then we have a little message worker, or a number of them maybe, probably part of the parking service, but still, working off this queue, sending the messages to the other services through our proper message queues. And this outbox pattern, or transactional outbox pattern, is a very robust way of ensuring that you reach consistency eventually. In practice, there is a small delay here, but I don't think it makes, it's not really a problem, let's put it that way. If you're building asynchronous backend, like APIs or products, there's also a sibling pattern called the inbox pattern, where you essentially store incoming requests before processing them, so that you don't lose them in case of a restart, in case of an upgrade, or whatever might happen in the middle of things here. And combining that with an outbox for callbacks, you pretty much ensure that you are at least not losing information, which is a good start. So persistence is good. Store things so that you don't lose anything if the system goes down for one reason or the other. At least upgrades happen every now and then, and we need to restart something at some point. And this allows us as well to update our state across the system, somewhat atomically at least. But talking to others across a network still comes with a lot of uncertainty or unpredictability. So let's move on to some things we can do about that. One thing we can do is to make sure that if we're going to fail, we might as well fail fast, by setting really low timeout values that still allows all normal transactions to go through. We ensure that we release resources as quickly as possible, like threads, memory, database connections, whatever it might be. They go back into their pools as soon as possible, making our system a little bit more efficient and giving it a little bit more headroom to deal with other problems. But also, timeouts turn just idle waiting into an actionable event. Now we've waited long enough, let's do something about it. So this becomes a point where we can attach other resiliency mechanisms, if you will. But timeouts can be a little bit wasteful if you don't treat them carefully. We had a bit of a tragicomic situation a few years ago where we had a partner, a parking operator, that wanted to fetch all their active parkings every second minute. So every 2 minutes we got a request. Hello, please give us all our parkings, please. And we dug through our database, finding all those parkings, and sent them back, and everything was fine. But then they grew, and we grew, and the database grew quite a bit. And this request wasn't really implemented in maybe the most ideal part of the system. It worked well when we were small, but not so well with time. So maybe you see where this is going, but they had a pretty liberal timeout of 1 minute. But after a while, we reached that 1 minute. It took more than 1 minute to get their parkings. So all the time, every day, throughout the year, we spent more than 1 minute every 2 minutes finding their parkings, and they never got the response. So, yeah, not ideal. And this just goes to show that reviewing and following up and adjusting these limits is a pretty good thing to do. And some timeouts, I think, can also be a bit scary, because a timeout doesn't mean that nothing happened, right? It's easy to think about it like that, like, oh, I got a timeout, they're probably down, the system is down, no problem. But they might have still done things, just like we did things, finding all those parkings before the other guys hang up on us. And we have a situation, or not a situation, but we have an interesting case in the city where we normally operate in the way that we are the source of truth for what parkings are active. So when you ask us to start a parking, we start a parking, and then we can inform the city about that, either immediately or in a monthly report, basically. But one city is doing things a little bit differently because they want to be the source of truth for parkings in their city. So when we get the request from the app, like in the diagram before, our backend can't just start an app. It must ask their systems to start or start a parking. We must ask the system the parking for us. Sorry about the sound. I hope you can hear me. And this is fine if they say, yes, we could start a parking, no problem. Or it's fine if they say no as well. Well, then we can just apologize to our users and say, sorry, we couldn't start a parking for you. But if we get a timeout, then what happens? I mean, we can still tell our users that, sorry, we couldn't start a parking, but a parking might still have been started. And we as a company are still responsible for paying for that parking, even though we won't get paid. So we want to get rid of that as quickly as possible, if there is a parking. So if we end up in that scenario, we immediately try to stop the parking again. Like, you know that parking 1 through 3 that we just started, please stop it. And if we don't get a response, we just try to stop it, until we get back like some kind of response saying either, okay, it's been stopped, or we don't know what you're talking about, there is no such parking, which is great. So timeouts, they are more tricky than they might appear. So we have ensured that we are failing fast, but then what do we do? In some certain scenarios, if you're returning data that is going to be built into something displayed to a user, you can sometimes get away with returning something else instead. Maybe you have cached information that you can show. Maybe you can replace part of the response with something else. Like if you have a product page and you're supposed to show like personal recommendations for other products, if that fails, maybe you can show popular products or something else instead. And this can be pre-calculated like daily or every hour for each category or products or whatever. You might have something to patch up the failure so that like the user probably won't miss it, but at least, so I mean, it's about handling the situation in a graceful manner, basically. But this is a pretty slim case, I would say. When you have the opportunity, it's a good thing to do. But most of the time, the most common action to take when we get a timeout is, of course, to to try again. And having tight... Is there something I can do about this? Nope. Okay. So having tight timeouts relies on being able to try again, essentially. And in many cases, that second attempt or the third attempt solves it. But of course, not every error should be retried. If you get technical problems, like network is down, or we get a timeout, or whatever, that should definitely be retried. But validation errors, or in some cases, there are pretty complicated business rules for what can be retried and not. So be a bit careful with what you retry. And don't just retry like every second forever. It's very nice to back off a little bit between retries. Maybe not just a little bit, back off exponentially, so that we add more and more waiting time in between the retries. Plus a little bit of randomness, like a random jitter, so that we don't create spikes of retries like on specific moments. That is probably not appreciated by the other system if it's already struggling. But to make retries safe, the operation itself must be idempotent. And this essentially means that performing the same operation over and over will yield the same end result. So that we don't buy an extra parking ticket for every retry or charge your credit card an additional time every time you retry. That is frowned upon, I think. And this is done on the server side mostly by identifying sameness. Like, is this the same request coming in again? And this is usually done by having the client in this relationship providing an idempotency key or ID for each request. And of course, reusing the same one for retries of that request. And that way we can tell apart like two separate intents to buy something for 100 kroner from a retry of a single intent to buy something for 100 kroner, because those might look exactly the same otherwise. And the server can then store, like get a request, perform some action, store this idempotency key along with the response for that operation. And if it sees the same request again, just send that response back a second time, or at least one more time. And for every jump we have over one of these idempotency boundaries, we must ensure that idempotency is guaranteed. So we should discuss with the partners we integrate with how they solve this, what support do they have for idempotency, and if they don't, which happens, we should strongly encourage them to implement this, because otherwise we'll end up with all sorts of unwanted side effects when we do retry things. And we want to retry. I think that it's like a crucial part of having a reliable integration set up. So if we have idempotency in place, retries are pretty safe. But what happens if something keeps failing anyway? We talked about the outbox pattern before, and that is a really good foundation for retrying from. Like you won't lose what you are trying to get through. But if you have a failing request at the front of the line, so to speak, if you have a strange request that for some reason causes like an internal server error on the other side, then the queue will get stuck. Like, nothing will get through. And we can solve this by introducing an additional queue, an error queue, or a retry queue, where failing requests go to be retried again. And this prevents temporary failures from clogging the main queue and allows like regular successful requests to keep flowing. So these failing requests are moved aside and retried later following some kind of a behavior we have defined. But that single tricky request can still keep failing, right? And then it will just block another queue instead. Now we have blocked the retry queue instead. And that isn't always so much better. So then we can add a third level to this, called the dead letter queue. And this is where the failures go, basically. And the only difference here is that these won't be retried automatically. It's more like to get them out of the way. And the deal here is that human intervention will be required to take care of these. So there might be something we can do. Maybe we have spotted an error, we have spotted a bug in our systems, and we just have to tweak something with a request before sending it off again. And then we can put it back in the outbox. But this ensures that we move both temporary and more, stubborn failures out of the way to keep as much traffic as we can going. So again, retries are pretty crucial to making integrations work, but it's important that we just retry the right things and that we do it respectfully, exponential backoff, random jitter, all that good stuff. We can avoid clogging our nice queues by moving things over to 1 or 2 times, maybe. And it's really critical that we ensure idempotency at each step of the chain, if there is a chain of requests. So let's move on to a couple of practices that we can use to protect our system, both by containing and isolating failures. The first one being circuit breakers, which is essentially a mechanism that observes the success rate of, well, any operation really, but for example, a network request. And it protects the system by actually not retrying most retries, just rejecting them immediately instead, which eases the load on both our system and the other party quite a bit. You know, we said that failing fast can be pretty useful, and there's no faster way to fail than to not try at all, right? Something you can tell your kids. Here's another little chart for you. Here we can see the circuit breaker sitting there between our outbox and the service. You can imagine animated boxes flowing here. I couldn't get that to work really, but if a problem is detected here, if we start getting like timeouts or other failures, the breaker will flip, just like an electrical breaker. And when the breaker is now open, that means traffic is closed, ironically. So nothing will go through. Attempts will be failing immediately, really quickly. But that wouldn't be all that helpful. So what we do instead is that we let some of them through. We use the occasional request to probe, like, are we up again, maybe? And when enough of those succeed, the problem is gone, and the breaker will close again, meaning traffic is open. Yeah, it's very confusing. Again, this protects our system from just useless retries. It doesn't help to retry if the other system is down, and we just use a few of them to test the waters a bit. And it also protects the other system, of course, from many, many retries when that is the last thing it wants, probably. Another way we can do these things is using a practice called bulkheads. And this is more about separating up resources within our system into different compartments so that failures are probably isolated into just one of these compartments while the rest of the system can keep working as intended. So if we don't have them and we have just one set of queues for our outgoing requests, for example, we have multiple customers or multiple integrations listening for the same things or through the same things here. If one of them is having a problem, we will quickly fill up that error queue. Maybe normal requests will still flow, but retries will be stuck until this one troublesome customer has sorted out their things. If we had bulkheads in place, we would have some kind of a division here into different compartments. For example, one per integration or one per customer, so that a problem with one customer would only block their own queue, which is exactly what it's supposed to do, right? We keep their retry messages until they succeed. And this works well in the other direction as well. If we have incoming requests or incoming traffic, we can separate other types of resources within the system into compartments, so that if someone is behaving badly, running out of things, only they run out of things, which is good. So yeah, to sum things up, we can protect both ourselves and others using these two techniques. And they work really well together, of course. We can have one circuit breaker per integration or per customer, so that we don't just stop traffic for everybody because one of them is having issues. So these mechanisms here, timeouts, fallbacks, retries, circuit breakers, and bulkheads, they are tools we can use to make our integrations more resilient from a technical perspective. But the trick is, of course, to use the right tools in the right places. And I guess this comes with experience, in part at least. So the most important places you can probably all sense from the beginning, like, this will be critical, here we will need this or that in order not to fail on day one. So you can probably catch those basically on gut feeling. Others will probably present themselves with time by failing, and then you know where to do what, where to add what, basically. Either way, it probably doesn't pay off to add everything everywhere, because that just doesn't make sense. It takes time, it adds complexity to have all these mechanisms for like in every corner of your system. So we should probably try to adapt the effort we put into this to the risk we see with each part of the integration. And for really critical integrations, it might be the right thing to do to add a lot of safeguards everywhere. But that is like on a case-by-case basis, essentially. So think a little bit about the return on investment of adding protection like this. And again, like many other aspects of building a resilient integration, make it evolve over time, let it show you where things are needed. And speaking of evolution, for something to evolve, there must be a feedback loop of some kind, right? A feedback loop starts with, well, if a loop has a beginning, I don't know, but one point in the loop is to observe something, right? And I'm sure you know the feeling that everything works great until you put it into production, and then everything goes sideways. Having an integration like this offers plenty of different opportunities for observing and measuring metrics and you know, dashboards and graphs and all of that good stuff. If you have message queues, for example, there are a number of things there you can track or get alerted if certain things passes certain limits. Of course, network traffic here, we can also observe things like people are not responding, or they are telling us illegal things that shouldn't happen. For example, we have alarms for different state transitions that shouldn't be possible. If an EV charging session goes from completed to active, that is not allowed, but it still happens. And that is can be the case when you're dealing with stuff sitting out in the rain, basically. They don't always work in a logical way when water gets introduced. There are a number of good metrics we can keep track of, such as latency, for example, to catch things before it's too late, like to catch the trends. I think that is probably a very good idea. Like observing a circuit breaker is a very strong signal that something is wrong, but catching these changes over time might be what allows us to catch something before it goes wrong. And I think that is very useful. If you use outboxes, measuring the length of those is also a very good idea. We actually have an alarm like this for this parking service that we talked about before, that has turned out to be a great, like a canary in the coal mine test for, not so much for an integration, but for the system as a whole. If this queue grows like unnaturally, that's a great sign that something within that service is not performing the way it usually does. So maybe a transaction has gotten stuck in a database or something like that. So you find these little nuggets that you get to know your system, you get to know your integration, and you find out which metrics are interesting to monitor, to observe over time, and to put alarms and alerts on. And once you have things like that, look for patterns, take time to have the occasional review of your metrics, find your situation, matching ours where we ended up just wasting a lot of time for no good. Finding that before it happens saves a lot of, money and embarrassment, probably. So revisiting rate limits, revisiting timeouts and so on, is very good practice. And update your shared documentation and other artifacts between parties of this integration. Despite our best efforts, things will still go wrong, and they will fail, and that is fine, as long as we use these as an opportunity to learn. So instead of, or in addition to building fault-tolerant systems, we should always try to build a fault-tolerant organization or culture as well, so that when things go wrong, it's not really interesting who did something. No finger pointing, no blame game, but we must understand why things went wrong so that we can we improve collaboration? Can we improve the way we do things? Can we add alarms, catching this earlier? When we have problems occasionally, we usually tend to react in two ways afterwards. We fix technical issues, like fix the core problem, but also add more alarms, maybe, fix the alarms so that we don't end up in a full-blown failure, but we might be alerted before we fail instead. And I think this is where a resilient integration is really born. We can't really avoid every failure, but we can turn every failure into an opportunity to learn. So, when you build your next integration, knock on wood, right? But prepare for failure right from the start. Thank you.